nomenclature is just something that takes practice. And so I think it also, part of the challenge is because it takes more work than maybe people think it should. We start to sort of question ourselves, you know, that internal voice that kind of questions, are you good enough? Or the imposter syndrome, you know, do I really belong here? It kind of kicks that into gear. Even if you're not a person who necessarily struggles, like you feel like you're a smart person, then when you make a mistake here, it's like, oh, I can't believe I just made that mistake again. But it gets better. And I've seen it get better as students continue to apply themselves. Okay, so maybe that's everybody who's going to be here. I'm going to go ahead and get started. So nomenclature is just the system of naming, and many disciplines have their own nomenclature. So it's kind of like the language that we use to communicate ideas. Just like when we learned that the periodic table is full of symbols that communicate a name for an element, and there's a lot of meaning in that. Same thing with nomenclature. Oops. Okay, things we can name. We can name elements. I just want to remind you that there's 3 kinds of elements. Typically, elements are monatomic, which means one atom existing by itself, maybe next to other atoms in a solid or a liquid. And so an example of a monatomic element would be something like, I don't know, iron metal, or carbon, or a metalloid, boron. And then there are diatomic elements. How many of those are there?
7.
7. And what are they? Go ahead and just say them to yourself before I write them out.
That's 7.
The 7 starting at 7? Yeah.
On the table, yeah. Well, that
So for you, your order would probably be nitrogen, oxygen, fluorine, hydrogen, chlorine, bromine, and iodine, something like that, because that makes that 7. Okay, but you have to know those, because as we go throughout the course and in the next course, when you hear somebody say iodine, you need to think I2. That is a diatomic element. That is an element that's held together through covalent interactions, electron sharing. And then there are polyatomic. And how many of those do we have?
3.
In our class, there are 3. So everybody stop and think, what are the 3? Okay, so we know how to name elements, and we learned the symbols and spellings, but we now understand that the symbols for 10 of these aren't just 1 letter or 2 letters. They involve a subscript, and we need to know that. Okay, so we can name elements, and we can name ions. I'm going to need a new page for ions, because ions is a big page. We have the ions that are cations. And the ions that are anions. And then think to yourself, what does cation mean? What does anion mean? So cations have what charge?
Positive.
Usually cations are often, they're monatomic. I would say usually. And so we might have the kind where we just write the symbol, and the name is calcium ion. We add the word ion. Oops. And then there's this kind where we have to, we write the symbol, but we have to state what the charge is also. And this would be copper 2. Like a first name, middle name, like Mary Ann or Susie Lou, Cindy Lou, Cindy Lou Who, copper 2 ion. And then there is 1 diatomic, and there is 1 polyatomic in our class. The diatomic one really vexes people. People don't like this. I'm sorry. But it really is, and we sometimes need to talk about it. And that is mercury 1 ion. Mercury 1 ion has 2 2s. Why? Because a mercury 1 ion is not stable. And so they travel in pairs. And I can't say they're covalently bound, it's sort of metallically bound, but they're bound in a way that makes them a chunk of charge. And then the polyatomic ion is super important, and you need to know it. And you know it's 4 hydrogens with a +1 charge. That is ammonium ion. Anions are negatively charged ions. And there's typically, I'm going to say 3 main flavors, but there are derivatives. The first one we learned were the ides. And an ide is just a nonmetal atom. Even if it was a polyatomic element, this is a different way for it to become stable, that has gained electrons. So sulfide has gained 2 electrons to be isoelectronic with argon. So sulfur, as we find it on the periodic table, is not stable, but nonmetals have 2 ways to become stable. One is through sharing electrons, and one is through gaining electrons. And so if they're sharing, they don't need to gain. And if they're gaining, they don't need to share. And so this is a covalent way of being stable, and here's an ionic way of being stable. There are the 8s, and now we're at the polyatomic anchors that I was thinking of. Nic stands for nitrate. The camel, eta clam for separ, and phoenix. I did not plan well. So you just have to know those cold. Nitrate kind of does its own thing, but these 4 are the line leaders, and they determine how similar nonmetals will behave in this polyatomic situation. So below carbon on the periodic table is silicon. And if carbonate gains 3 oxygens and 2 electrons to form a chunk that is stable, silicon gains as many oxygens and as many extra electrons. So I don't have to memorize silicate. I can just find it on the periodic table and see that it's below carbon. And so carbon determines, carbonate tells us silicate and germinate, phosphate tells us arsenate, sulfur tells us selenate and tellurate, and chlorine, this group 7 is super important. Once we know chlorate, we know bromate and iodate. So those are line leaders. So if you see something like this on a quiz or a test or something, you know, that's not selenium tetraoxide ion, it's selenate. How do I know? I find it on the periodic table. I look above it till I find the line leader, and I see what the pattern is: 4 oxygens, 2 extra electrons. So once we know the 8s, we know some derivatives. And so things in a column behave in a chemically similar manner. If I know carbonate, or if I know chlorate, I know bromate. The next thing is, if you lose 1 oxygen but have the same charge, it's an ite. So we're talking about oxyanions, negatively charged chunks that contain oxygen. If I know bromate, I know bromite. Then there are hydrogen-containing oxyanions. So if I know sulfate, and I add a hydrogen and it's still an ion, it's hydrogen sulfate. The charge went up by 1 because hydrogen was missing an electron, and so that neutralizes this just a little bit. And then there are the group of 7. So in the 7th column, there are more possibilities. So we are only talking about chlorate, chlorine, bromine, and iodine, and what they can do. Of course, chlorate could lose an electron and become chlorite. But in group 7, there's more possibilities. Chlorite could lose another oxygen. Did I say lose an electron? I meant lose an oxygen. Oops. And it's below the ite. And so this is hypochlorite. Above chlorate, one oxygen more, is perchlorate. So group 7 can do that. There is a coincidental thing. They're unrelated. They just happen to look the same, so it might help you memorize. And that is, there is a real thing called permanganate. But it doesn't follow the rules. So that one you have to know. It's on your list of things to memorize. It doesn't follow the rules because to become manganate, it gains an extra electron. That is a real thing, and that is not helping us. So this rule of adding an extra oxygen or losing an extra oxygen only applies to group 7.
Is this always in reference to how much oxygen each one of them have in a given formula, or is it 2 is 8 and then 3 is 8?
No,
Is this
because, yeah,
okay.
that's a good point. So for nitrate, carbonate, and chlorate, 8 is 3. For
Okay.
sulfate and phosphate, 8 is 4. And it comes down to 8 is just the more stable or most stable combination that is found. So ites are less stable, and they will spontaneously, like just being exposed to oxygen in the air, turn into 8s.
Okay, thank you for clarifying.
Sure. Okay, so we have ides and 8s, and the 8s have derivatives, more possibilities. There are some that don't kind of fit, and we have to just memorize them. And so here's a couple kind of exceptions that need to be known. Like cyanide, that's a diatomic anion that ends in ide. Okay, the reason it doesn't make sense is ides typically are just one element, but here we have 2 elements together. So that's not helpful, but it is real. We have to know it. Hydroxide is the strong base that is going to be super important in life and in chemistry. And again, it ends in ide, hydroxide, but it doesn't really follow the rule for what we think ides are. And then there are 2 oxyanions that contain the word di. And it's frustrating because we save those Greek prefixes typically for covalent compounds, and we're just talking about making anions. So if it helps, keep in mind this: all these chunks of charge, when more than one atom is bound together with extra electrons, that's actually a covalent chunk that has become an ion. I don't know if that helps, but for example, dihydrogen phosphate is real, and it has a di in the name. And dichromate is real, and it has a di in the name. And an 8. Just really not helping us. Okay, so we can name ions, and then we can put those ions together in a way that the charges add up to 0, and we call that a compound. We don't show the charges when ions are in compounds. Okay, what can we name? We can name elements, we can name ions, we can name compounds. And there's 2 main categories of compounds. There are ionic and covalent. We spent a lot of time last week talking about ionic compounds, so I'm just going to go straight to covalent. For covalent compounds, there are 4 categories that we use. It's a way of categorizing so that we can name things. And the first 3 categories all have hydrogens. And the 4th category, which people typically love, have no hydrogens. So if you're going to say how many of each kind using the Greek prefixes, there's no hydrogens involved. Like this covalent compound, I know it's covalent. I know it's a compound because there's more than one capital and no charge showing. I know it's covalent because the first symbol there is a non-metal. It's not a metal. And then we say how many of each kind. So we say dichlorine And I'm using for the first one, the elemental ending. And then for the second one, we're going to change the ending to "ide." 7 is hept. And we would say heptaoxide, but whenever we have the prefix ending in A or O, and the word root beginning with A or O, we drop the prefix vowel. Okay, so the second element is given the "ide" ending. So everybody prefers those. Let's get our Greek on. Okay, but the other ones are important too. So here, the first category would be, in the order I put them, but obviously they can go in any order, are common names. How many common names do you need to know for this class?
5.
5. What's your favorite of the 5?
Water.
Me too. So take a minute and, scour your brains. See if you can come up with those. Water starts with H's, but all the other ones have the H's on the other end, on the back end. So right now you're all digging into your memory banks or maybe your notes, and you're looking for the formulas for these 4 common names. Ammonia is super important, NH3. It's related to ammonium. It has 1 H plus less. Methane is lab gas, and cows make methane, and cows have 4 legs. Phosphine is tweaker gas. On the periodic table, we have nitrogen, and below that we have phosphorus. So phosphine is like ammonia. And then hydrazine is rocket fuel. I just think of it as ammonia that's all souped up. So ammonia was 1 nitrogen and 3 hydrogens, and phosphine is 2 hydrogens and 2 nitrogens and 4 hydrogens. So if you were to name ammonia nitrogen trihydride, that would be wrong. This next bunch is important. They're all important, but they're important for different reasons. This next bunch are the hydrogen-containing gases. How many of these are there?
6.
When I think of these, I usually think of the halogens. So fluorine, chlorine, bromine, iodine. So fluoride can gain a hydrogen and become hydrogen fluoride gas. Oh, and then there are 2 that are in column 7. What are those? That was an actual question, not rhetorical.
Hydrogen sulfide and
Thank you.
hydrogen cyanide.
Perfect, good, thank you so much. So for hydrogen sulfide, if you wanted to name it wrong, what might you do? You're like, I don't want to name it wrong, Sue. I want all the points, all the learning. But let's just say if I was going to make a Kahoot and I had a wrong answer for hydrogen sulfide, what would be a good choice? Dihydrogen sulfide would be wrong. So for the hydrogen containing compounds, we don't say how many hydrogens. The next thing is all of these I put a G after, and the G stands for gas. And I didn't do that for anything else so far. Why have I done that?
Because acids are aqueous and you have to write that, and this is a gas, so you have to tell us what it is. And sometimes you'll have a little S for solids.
Yeah, so solid, liquid, gas, and aqueous are phases we might use as subscripts. And here, there's possibilities. If HF had an AQ behind it, it's no longer pure, it's mixed with water, it's a mixture. And it behaves as an acid, so we name it differently. So the next category, which is acids, gets its own page because it needs a whole page. Okay, so where were we? 1, 2, 3. We're under 3B3. And that's acids. There are 3 kinds of acids. They're the acids that come from ides, and those become hydroic acids. There's the acids that come from ates, and those are just ic acids, and that's confusing. Why hydro here and no hydro there? And the answer is it depends on the anion. And the ones that come from ites make us acids. Okay, so the ides that make hydroic acids, there are only 6. Here they are. These are ides because there's no oxygens. Ates and ites are all oxygen containing. So if the acid doesn't have an oxygen, it's a hydroic acid. Sometimes people think the hydro means that's because you added a hydrogen to make an acid. But really, the word acid takes care of the idea of adding a hydrogen. So hydros go with ides. My ride has hydraulics. This is hydrochloric acid. And sometimes they're not going to sound right. If I have sulfide and we add enough hydrogens to make it into a compound, and we end up with H2S, but now it's been bubbled through water, so we're going to name it as an acid. It's called hydrosulfuric acid, and that probably doesn't sound right. Why doesn't that sound right? And the answer would be probably because you have sulfuric acid in your life. You know, battery acid, that's sulfuric acid. So maybe that's a word that you've heard before. But hydrosulfuric acid is also real and super stinky. It smells like rotten eggs. Okay, if you have an 8, 8s make ic acids. The one that we're probably most familiar with is sulfuric acid. Have enough hydrogens that it's a compound. But now electrons are being shared. These aren't ions anymore. And sulfuric acid is actually kind of an exception. Let me show you the rule with something that's more typical, like maybe carbonate. It's early in the morning. We need to be gentle with the people that are still tracking, like still waking up, like me. Okay, so carbonate was the anion, but 8s make ic acids. So I'm going to cross out the 8 and write ic acid, carbonic acid. That's me applying the rule, how I'm supposed to apply it, how I apply it on everything except for sulfate and phosphate. Notice how we just took the root and we got rid of the 8 and added ic acid. For sulfate, we didn't do that. If we had done that for sulfate, it would have been sulfic acid. And instead of phosphoric acid, we get phosphoric acid. which is applying the rule correctly. It's just we haven't bent our ear to it yet. So let's say that on a quiz or an activity or a lab that you write sulfuric acid or phosphoric acid. I'm just going to put a little smiley face like, oh, look, you're learning. And you applied the rule correctly. Full credit. When you were a kid and you learned about past tense, and so let's say you're 3 or 2 or 4. Mommy, yesterday, Daddy and I, we go to the store. You know, do you know what your kid is saying? Yeah, you went to the store. Went is an irregular past tense verb. And so this is an irregular adaptation, and I'm totally fine while you're learning. But eventually, sulfic isn't going to sound right. Sulfuric is going to sound right. And then that's good too. Okay, so ates make ic acids, and ites make us acids. So nitrate is NO3 minus 1. Nitrite is NO2 minus 1. And if we gain a hydrogen to make a compound, the ite becomes an us acid. And sometimes to remember these, we have silly mnemonics like I ate something icky. At the White House. Or, if you prefer, ick. I ate a poisonous bite. So, icks come from eights, us's come from ites. So we can apply derivatives. And I could answer something like, this one's a little nutty. You know, what acid is that? Oh my goodness, I have no idea. We start by recognizing it's an acid. It's a covalent compound that begins with an H. Take that H off. What do you have left? I don't know. And then you think, well, I know that iodine is in the same column as chlorine. What is my anchor in that column? What is the 8 in that column? That's chlorate. So same number of oxygens and same charge would be iodate, the 8 of iodine. And then 1 oxygen more would be per iodate. And if we add a hydrogen to make it into an acid, eights make ic acids. It's per iodic acid. And so there's just a set of rules, and the rules can jumble in your head until you become more familiar with them, which is why we're spending a lot of time on nomenclature. Okay, so I'm going to warn you. Things are different online. Cheating looks different online. And again, I'm preaching to the choir, but this will go into Zoom, so maybe somebody else will hear this that needs to hear this. But sometimes students will look things up and they'll come up with a different formula because we're following a set of rules that may not quite match reality. It pretty much matches reality, but I'm going to look for things that maybe don't align correctly. Like maybe periodic acid doesn't actually exist, it's theoretical. So when you're doing these problems, use your notes, use your the lessons we've had, come up with your best deduction, your best guess, compare with your friends. If you differ, including differing on spelling, somebody's right and somebody's not right. If there's one time that's not true, I'm about to show you. And then if you have questions, ask me. Get assignments turned in early, and if you submit them early, usually I go through the assignments early in the week and I catch mistakes. So people that turned in standard deviation 1 or 2, by Friday, they got some feedback and they got to resubmit. Okay, so here's one. I don't know right now what that is. Hi, is it an acid or a gas? So I have to tell you right now I'm naming it as an acid. And then I pull off the hydrogen. And what do I have? An ide. And ides make hydroic acids. But if you Google this, of course you're not going to, you might find hydriotic. And they're both fine. So this O was hard to say and it's been omitted. But so besides that one example, if you and your friend have different answers, somebody's wrong. Which is not bad, it's just an opportunity to learn something. Okay,
This is
so at
the
this point, I
rule.
just want to, yeah?
Excuse me. This is the rule where if you start with an O or an A, you drop that letter or you keep it, right?
No, it's just a random exception.
Okay.
There is almost nothing in chemistry that doesn't have an exception. Sometimes I look back and think, why did I pick chemistry? Land of exceptions. Nobody likes it. Should have been a dance teacher, an art teacher, music teacher. Okay. So I'm going to do a page of just acids. If you need to take like a bio break, you need more coffee or use the restroom, this would be a good time to do it. I'm going to put up 5 acids by formulas, 5 acids by names, and then you're going to solve them. And then I'm going to mix all these things together. Because we've learned how to name elements, we can name ions, we can name compounds that are ionic, and then we can name covalent compounds. That's this week's stuff. Okay, so don't leave forever, but if you need to leave for a moment, now's the time. When you've made a good deduction, like when you've sorted out all 10 of these and committed something to paper, they don't have to be right, but they need to be on paper. Go ahead and just say, let me know that you're ready in chat. So I'm going to start at the top. I'm just going to recognize these are covalent compounds. They begin with H. Even this one, they're acids. They're all acids. So I know that the compounds are acids because they begin with H. And for the one that's an ide, it has an AQ. And then I know that all the names are acids because they have the word acid in them. Okay. I'm going to pull apart the hydrogens. And if I take 2 hydrogens off this, I'm left behind with an anion that's on a list I'm supposed to memorize. And it's called chromate. And 8s make ic acids. This is chromic acid. So you have assignments this week and 2 of them are nomenclature. And let's say that you were, you're doing the assignment because you've been assigned it, but also you want to learn. And then you want to turn it in and get points. But you don't want to do more work than you need to do. The work is to put it in your head. The work isn't necessarily writing unless that's how you put things in your head. If you have this whole string of stuff, which is a little bit messy, but shows your thinking, that is awesome. And then just when you get to the answer, make sure that you let me know with a highlighter or a box or a circle, you got there. That's where my eye needs to focus when I grade it. Because I do grade these for understanding, like by hand. I'm going to look at all your answers and make comments. Okay, and the other thing is, I don't know, some people haven't got the memo. I need you to write by hand. Just typing is not working. It's not working for reasons. And if you want to have a conversation about why, I can explain that at a later time. Okay, so I pull that off. I see I have this ion. Do I know this ion? Yes, it was on a list to memorize. This is acetate. 8s make ic acids. This is acetic acid. Or students sometimes say acetic acid. Isn't that redundant? Her. Okay, this is aqueous and it's an ide, bromide. My ride has hydraulics. Hydrobromic. Pull off 2 hydrogens. Oh, I think I already named this one, did I? No. Don't those look similar? That 2 and that R kind of resemble each other. So the first one was chromate, and this one is oxalate, and it is on a list of things you need to memorize. 8s make ic acids. This is oxalic acid. Pull off the hydrogens. I have SO3 2 minus. Oh, I don't think that's the one I memorized. Let's see, what is sulfate? SO4 2 minus. So this is 1 oxygen fewer. This is sulfite. And ites make us, OUS, acids. And it doesn't sound right, but it is right. So it isn't sulfus acid because sulfur and phosphorus do that funny keep the whole word part thing. This is sulfurous acid. But let's say that you just obeyed the rules and you wrote sulfus acid, OUS. And Chem 3A, full credit. Okay, hydroic acids come from ides. Cyanide. That's on the list we're supposed to memorize. Add enough hydrogens to make it a compound. Us acids come from ites. I didn't memorize nitrite. I memorized nitrate, but ites have 1 oxygen fewer. Add enough hydrogens to make a compound. There it is. Ic acids come from 8s. Carbonate. It has a -2 charge, so I need to add 2 hydrogens to make it neutral. Carbonic acid. Ic acids. Ic acids come from 8s. There's chlorate. Chloric acid. Us acids come from ites. I don't know iodite. Help. Iodine is in group 7. The line leader in group 7 is chlorate. So I start with chlorate. And then iodate is going to be iodine with the same oxygens in charge. And then iodite is going to be 1 oxygen fewer. And add a hydrogen to make it an acid. Iodous acid. Alrighty, so the last thing I want to do is the same idea, 5 formulas, 5 names. This time I'm going to mix together all the things we know how to name. The 4 kinds of covalent compounds, an ionic compound, some elements, things like that. I was walking down the stairs and I heard people leaving. Doo-doo, is how it sounds on my end. For those of you that are still here, good for you. When you're ready, just put that in chat again. Oh, you know what's funny? And when the person leaves, their name in chat, you know how it says from this person to everyone? Oh, actually, never mind. I shouldn't talk. Anyway, there's a clue. I know who left. Ready-ish is good enough. It's been an hour. But yeah, your chat doesn't go away. Your name just turns a different color. Okay. The first one is a covalent compound, and it has a common name that we should know. The second one is an element. It only has one capital, no charge showing. The third one is covalent because it starts with phosphorus, which is a nonmetal, and it doesn't have any hydrogen. So I'm going to say how many of each kind. The fourth one is also a covalent compound with no hydrogen. So it's also how many of each kind. It starts with a nonmetal. It's phosphorus day today. The next one, though, is not covalent because aluminum is a metal, even though it touches that stair-step line of the metalloids. So I'm just going to name it as an ionic compound. Aluminum ion and bromide ion come together in a ratio where their charges add to 0. And I don't say aluminum-free bromide because it's a fixed charge cation. Okay, ammonia is on the list of things you just need to memorize. Iron 3 is a metal with a +3 charge. Oxide is a -2, shoot for 6. Barium is a metal with a +2 charge because it's in group 2. And hydroxide is a polyatomic with a -1 charge. So I'm going to have to use parentheses to say 2 hydroxides. Sometimes I see this wrong, like this. That's common. But that's saying 1 barium, 1 oxygen, and 2 hydrogens. And what we really mean is 2 hydroxides. Acetic acid. Ic acids come from ates, and this is acetate. Ic acids come from ates, and if it were chlorates, it would be ClO3 -1, but it's perchlorate. So there's 4 oxygens. Questions? Okay, that's all I got.
I just have one general question. For
Sure.
nomenclature, obviously we should work through the packet. Like, what's the best way? Work through the packet and then make flashcards and then study, or like,
Yeah, and I'm going to put up some mixed nomenclature reviews. I can do that today.
Okay.
So on the front page, I started posting keys, and I'm going to continue to post keys. And so you probably need to know where to find them. Under here, under resources on our homepage, it says keys to worksheets.
I see it. Okay.
So here's the problems 132 and 134 and the standard deviation keys. I was thinking I should probably have under resources just a packet that says nomenclature that links you to nomenclature practice and the keys for the practice. So look here under resources to find nomenclature a little later today, and then you'll have mixed practices. I have like 9 of them. When you do them, don't do them all one day.
Yeah.
It's like practicing piano or building a muscle. You practice the skill a little bit every day. And as your strength increases, as your ability increases, you practice a little longer every day. But you would never like prepare for a marathon by running 13 miles, the day before.